This is a program that is a correction to the exercise concerning the introductions of public administration into the model we have already defined. I'll always start with a comment and the definitions of sectors, the alias, then a list of parameters. There are new parameters corresponding to the initial values of the new variables of my model. So, for example, disposable income, total public spendings, and so on. Then I enter the data in the form of a new social accounting matrix. It is always a contraction of the matrix which is contained in the Excel file. This new matrix has a government column and a government row. So this is the change as compared to the previous program. Then I use this matrix to give values to a certain number of parameters, like labor demand by sector, capital demand by sector, intermediate consumption, and so on. Be careful, because I do not here enter the tax rate, but the amount of tax collected by the state. So it's not the indirect tax rate and the income tax rate. It's the amount of taxes collected by the state. So for indirect taxation, there is data coming from the social accounting matrix at the line GVT for government, and in the column of each sector. So it's 100, 220, and 180. For direct taxation, it is still in the government line, but it is at the household column, so it is 3,700. Then our normalize prices. Here we must be very careful, because I cannot normalize all prices, because in fact there is a relationship in the model between several prices, in particular the relation that links producer price and consumer price. That is to say, consumer prices equal to producer prices times 1 plus the indirect tax rate. So this relations in the model means that I cannot normalize, that is to say equal to 1, all prices. So what I did here is that I started with normalizations of the production prices. Py is equal to 1. So I then have to calculate the indirect tax rates. I can use the formula which I explained in the video. And once I have given a value to this indirect tax rate by sector, I can give a value to consumer price. And you understand that if I normalize production price to 1, I cannot normalize consumer price to 1. I have to give a value which is consistent with the equations of the model relating production price and consumption price. So it's very important to do this, because otherwise macroeconomic relations will no longer be balanced. Just look at the social accounting matrix. So here, if I give a value of 1 to Py and then say that the consumer price is higher than the producer price, I have to readjust the consumption volumes. If I don't, and so this readjustment of consumption value is done here. If I don't, well, it means that I will unbalance my social accounting matrix. For example, in its utilizations of the income of 10,000, household make a final consumption expenditure valued at consumer prices, so 1,700 in the agricultural sector, 1,200 in the industrial sector, and 2,400 in the services sector. So if I keep the same volume of consumption and multiply it by a consumer price greater than 1, I will create a utilizations of income which is greater than the total income. So I have to correct by dividing consumption here by consumer prices. And to keep my balance between supply and demand, I have to do it also for production, because I have to do it also for intermediate consumption and public consumption. So you must be very careful here, because in fact you have a normalizations of production price at 1, and then it means that consumer price is greater than 1 because of indirect taxation, and so you have to readjust the volume of consumption such that the value of consumption is equal to the value given by the social accounting matrix. Okay, before that I started the calibration by writing a divisions of LD0 by W0 and KD0 by R0. In fact, W0 is equal to 1, R0 is equal to 1, so this doesn't change anything. It's not actually necessary to do that. In fact, I wrote these assignments only in case that W0 and R0 were different from 1. Okay, so then I continue the calibration using the parameters to which I have already given a value and using equations from the model. So I give value to supply of labor and supply of capital, then value added, then alpha, which is the share of demand for capital in total value added, and so on. Okay, there is nothing new in the rest of the calibration compared to the previous model, but you have to be sure that at the end of the model, at the end of the calibrations, all model parameters have a value and all model equations will be respected. Then I declare variables. I initialize variables of the model. I declare equations. And now this is the model. It begins with a block prices. So this is the relation between production price and consumer price. Then we have the production block, and this block is not modified as compared to the previous model, except that I use producer price instead of a unique price, which was in the previous model not only the producer price but also the consumer price. So here you have to be careful and use the producer price. Then you have the income formation block. It is new because now there is a distinction between income. Income is determined by the ownership of productive factors, but it is different from disposable income. And the difference comes from the income taxation. The income tax rate, ITR, was previously determined during the calibration here by the division of the amount collected in direct taxes by households' income. Okay, in the model, then we have the consumption block. So concerning the consumption block, it doesn't change, except that the budget allocated to consumption is different from income. It is disposable income, it is not income. And then we have now a block which is government. And so we have two equations. The first equation relates the equality between total income, total revenues, public revenues. So on the left side you have total revenues, on the right side you have total expenditure. Total expenditure, I call it budge underscore exp, and revenues are direct taxation on households and indirect taxation collected on the sales of goods and services. Then you have here, once the budget expenditure is determined by the previous equation, the distributions of public expenditure between the three sectors is explained by a Cobb-Douglas. And so in the Cobb-Douglas, you have each sector's share in value of total public expenditure is constant. Finally, we have a block which is market equilibria. So what is different is the market equilibrium for goods, because we now have one public demand by sector. If I run the program, I see that the model is well calibrated, because in the process window, the first solve, it is starting with an initial infeasibility which is very close to 0. And then the second solve, it starts with an initial infeasibility which is 740. It's normal because now equations of the model are no more respected. If I look at the solution, so I can double click on model statistics, I see that now there is 48 equations and 48 variables. If I look at the results, so I remind you that in my modeling I implemented a decrease in the indirect tax rate. So if I look at the impact on the economy, you see that there is an increase in the private consumption in every sector. So it has a boosting effect on activity, but it is offset, and so the impact on production by sector is in fact it is positive in agriculture but negative in industry and services, so it's not very good. Why? This is because in fact the public budget in this model must be balanced. So if indirect tax rates are reduced, the public revenues fall, and therefore the public expenditure must fall. So in fact, the boosting impact of private consumption is offset by a decline in public consumption, and so the effect on production is close to 0.